Okay, hello everyone. Welcome to our first session for HCIA Data Comms. So this one is titled Data Communication Network Basics. Basically, we introduced what communication is, what data communication is, what a network is, and what makes up a networks, what makes up a network. Um, why do we need networks? What are the type of networks that we have? If you're ever going to be a network engineer, what will be your roles? What is network engineering? These are the basics. So I'm just going to be browsing quickly through slide read, trying to find kuti tinechi. To begin, objectives. Understanding the concept related to communication and a data communication network, be able to describe information transfer process, differentiate network devices, understand different types of networks and topologies, understand concepts related to network engineering and network engineers. Icons. So my icons, Ada, I think they are very important in the sense, where are we in Africa? All right, they are very important in the sense that they allow us to represent devices in a network diagram. So you're going to be having my diagrams which represents my networks, and you need to familiarize and my icons are because they'll be representing my devices. So for example, the first one is your router. So on a network diagram, or something like this, it basically means it's a router. So if we go through all the icons are repo, with respect to ACIA, Huawei, these are the icons that will be used. Communication networks. The concept of communication is very simple. Refers to information transfer and exchange between people and things, between things through a certain medium and behavior. That is what communication is. Exchange of information. That is communication. Kana ndichitaura newe face to face, we are communicating, we are exchanging information. Now, isusu, we're dealing with network communication. We are adding a network to that. So we are exchanging information using an interconnection of devices. My devices, our computers, my routers, my switches, interconnected by network media. That is basically what network communication is. Communication, exchange of information, network communication, exchange of that information using a network. A network, a couple of elements interconnected with media. It can be wired, it can be wireless. So, in summary, network communication is a form of communication. Isusu ndio yatinodhila nayo in HCIA. Its importance, I think, is very evident. Importance in network, exchange of information here, we do that. Education, that really is we're using a network to do that. Business, entertainment, quite a number of things where networks are very critical. Information transfer process. So here we have an analog. Visual information transfer is similar to real object transfer. So here we have an analog which will be used to explain how information is transferred through a network. So you can see this one is representing real object transfer. Where's my pen? This one. So on the dot transfer, probably this phone. Some package, ndoendesa distribution center, yokwira ndege, yosvika in another distribution center. Distribution center ndere paHarare, iro ndere paBulawayo, then package yosvika kwainofanira kusvika. So that analog is the same in how information is transferred using a network. Object redu, as you can see, ndo data, iro ndo object ready. data we're going to be sending originating from a computer. Then data will need to be packaged. The reason why we package phone yedu yaungosenda yakadaro unoisa box oiputira probably kuti isatsemuke, probably kuti vanhu vasaona kuti chii, that's security. The same way we do packaging yefoni iyo is the same way we have packaging ye-information yedu. Encryption is a form of packaging kuti information yedu ive secure, right? Then data packaging toendesa pa-distribution center. I think tokuenda pa-post office ndo pawakunosiya post office redu kunetwork ndo iro. Post office redu rokwidza ndege yedu ndo internet. Information yakuenda pa-internet yosvika on another distribution center, packet rovhurwa, then kana ravhurwa toona data yedu. So along the way, if you go through the PDF that we gave you, you'll be learning about my terms like encapsulation, de-encapsulation, adding of headers and trailers to payload redu. Those but basically on this slide, we are trying to understand how networks work using an analog. If you're trying to send something over using post office. Right. James, learn kuti mukapinda meeting always mute. Learn mukapinda meeting always mute. By default. Right, common terms, data payload, that's our information packet. That's a PDU. That's a form of information as well. Header, tail, that's extra information that is added to packet redu during the process here. Encapsulation, then kana takubvisa header and trailer, takuenda pa-process inonzi de-encapsulation. Then the gateway, that is the gate out of the network, which provides a way out of the network basically. Then network device that provides functions such as protocol conversion, route selection. Okay, this is the gateway, not the default gateway. So that's our router in the case. Yeah, analog nayo. So gateway and router are probably the same thing. Terminal device, ndoma phones edu, ndoma laptops edu. Those are the end devices. Common terms. This is it. This isn't much. The concepts of data communication network. Communication networks consist of routers, switches, firewall, access controllers, access points, PCs, printers, servers. I think those are the devices we'll be dealing with during program Yedu. And you need to understand each and every device, familiarize with it. What is its function? What is the role that it plays in networking? So you can see that's a network here tonight, image up, and it's made of this is a switch, that's a firewall, this is a router, we have a router, we don't have my end devices, this is a wireless device, my icons are akudzoka, and you need to understand every icon to know that's a wireless device, probably an access point. Like I was saying, I think here you just you need to have knowledge yekuti the devices that makes up a network akaita sei and what are the roles they play, because they play different roles. Starting with my switch, these are layer 2 devices closest to the end user that connects devices within a local area network. So kana tine a LAN, the device that connects the switch is a layer 2 device. It sort of works as a distributor. Can I trip a network? And if I have a switch, if I have multiple devices connected, 1, 2, 3. So information can send from a PC to another PC, each act as a distributor. Ndo chinotambira chodistributor chiendesa kwairofana kuenda with respect to layer 2 information, which you will soon learn anonzi MAC addresses. So distributed network on a local area network inonzi switch. Then toenda router. Router, that's a layer 3 device uh, used in implementing communication between networks of the same type or different types. Router, it connects my networks. It isolates my broadcast domain. I'll quickly go run through this. It maintains the routing table. It selects routes, implement wireless access, wide area network access, then connecting layer 2 networks. All right. Router, it connects my networks. In simple terms, chandatanga kuintroduce another switch, layer 2. Switch, connect devices on a local area network. So if you check my devices 1, 2, 3i, these are the devices that makes up my local area network, iro. Local area network, iroro, represents a broadcast domain. Why? Because in the said broadcast from any of the devices within my network here, it will definitely reach my device SI, meaning it's a broadcast domain. Then kana Buddha, this is another network ish. In the switch, my devices 4 and 5. That's another network. Between my networks angle, we have a router. When I say the router, it interconnects my networks. That's the function in router. It interconnects my networks. Ndikabvisa router iri ndikaza switch up. Then network yes ish. It's now only one network. So in terms of my devices, you can see with the switch, it is just used to enable my devices within the same network to connect. Then a router is used to separate my networks. Could unoita network 1, network 2, then they're both interconnected by a router. I think that's the main function here, router, main distinction which we can use to define a router and a switch. Then kana takudhipisa, we'll go to the issue to do with routing. Router, it is then used using the routing table, using my routing protocols to find the best pathways within pathways to a destination. Can I send the information? So if I'm sending information from network 1, where are we in Africa? Right. If I'm sending information from network 1 to network 2, let's say we have another network 3 connected to that router. Router and responsible determining the best way could this to the destination. Do you know what I say? How does it do that? It uses yet not routing table. Routing table and again all the information about my routes, and that's how a router knows how to do that. So in short, a router redu main responsibility finding the best pathways to the destination. It's a layer 3 device. It separates my networks. It isolates my broadcast domain. On the other end, switch rako layer 2 device. It not my collision domains. They were not highlighted here. You need to learn about this. Country will switch to Delaniana's my collision domains. Then switch redo no separate my collision domains. Whilst the router redo is isolator my broadcast domains. Separating, I think same thing. Another device firewall. This one is more to do with security. Firewall basically controls incoming, outgoing network traffic, usually based on a set of rules that are defined within an organization. That's what my policies are, using my security policies. So you define a certain set of rules. Could the information over a PCA should not be allowed in this network? Then firewall, it uses that set of rules to block every traffic over from PCA. Basically, that is what a firewall is. You can see it has other functions. It's popping up, implementing other security functions, implementing network address translation. I think over time we'll learn about that. Data encryption, remote access, VPNs. I think it is used for stuff like that. User identity authentication, AAA services, access control, isolating networks of different security levels. That's our firewall. Firewall, if switch really distributor, sort of number 10, and one sister within the team, firewall the goalkeeper, keeping goals out of the net, security, dopamine security, yes. Then we have my wireless devices, basically used for wireless access. Dopamine wireless access points in, dopamine controllers. We'll soon learn about that as well. I think those are the set of devices, I think the common, which you need to familiarize with. Turn up on my types of networks. Type of networks, tinema local, tinema metropolitan, and then tinema wide area networks. My networks they're defined by the sizes that they have. LAN, MAN, WAN, with increase in size, LAN being the smallest, which is not always the case as we will learn as we go through the program. But for now, let's just define it in terms of coverage. Local area network, smaller size. Metropolitan, uh, municipal, provincial networks, a bit bigger. Then a wide area network can cover the whole country, the whole world. Perfect example of a wide area network, the internet. Internet is a typical wide area network. Type of networks, BO. Topologies. Network topologies are basically what we use to describe the physical and logical structure of a network. If you're ever going to design a network or raise a network for a certain company in a multiple branches within a city, you need to design that network. Designing will start by coming up with my topologies, physical, and logical. Physical topology, probably something like this, E topology. Physical representation, yokuti network yako ichange yakaita sei. That's a topology. So the physical topology will probably show you kuti device rakati rinenge riri papi, rakakonectana nerimwe device riri papi. Location, that's a physical topology. Then with the logical topology, which shows us the logical connections within those devices. Device A, router 1, rakakonecta nerouter 2 using my ports API, using my interfaces API, connecting using my IP addresses API. So in totality of all that, topology, it gives you an idea yokuti design network yako inenge yakaita sei. It's sort of plan architecture. Plan inogadzirwa nearchitecture inonyorwa pasi kuti imba yako inenge yakadai, door rinenge riri pakati, ine marooms mangani. That's the same thing with a network topology. Before you build an actual house, you need plan. So iyo ndo plan yedu. That is what the topology is. Type of physical topologies that we have: bus, ring, tree, full mesh, partial mesh topologies. I'll leave that to you. Put my type of my topologies that now in the API, and which ones are the best for a given scenario. So depending on the type of network that you want to design, you probably need one of these type of topologies. I think the most used one is probably the star network topology, and maybe the mesh. While in networking, I rarely see them being in use that much. Topologies. Network engineering. What is network engineering? Network engineering refers to planning, designing feasible solutions based on network applications. Okay, so basically, network engineering it's planning, strategic planning. Designing, after you plan, you design, then you integrate, interconnect a number of components so that you can build a functional, cheap. Can I use cheap? Functional, let's use cost effective. Cost effective network. That is what network engineering is. Planning, designing, integrating components, cost effective. That is basically what network engineering is. It will have a number of components within it: application, storage, security, calculation, wireless routing, switching. It involves everything. You don't bring the Wakura. So that is what network engineering is. So by the time I'm now a network engineer, it means you are strategically planning, designing, integrating components to make up a cost-effective network. Some of the skills that will be required of you, do SRAPA. You can go through this. Kwete kukrema and copy and pasting. Probably that's not a very useful skill, but mamu ayo. Those are the skills that will be required of you. And with that, probably we're very close to ending our session. What we have here, network engineers technology development path. What routing and switching, how to perform, verify OSPF configurations. That is part of what you'll be doing as a network engineer, basically. Solution design, network planning, implementation, troubleshooting, and optimization. I think this is what you'll be responsible for as a network engineer. That's the ultimate goal. Kana takuti engineer, you should be able to do some of those stuff. And certification program yedu CIA is with the hope that we get you to point it at the top here, being able to design, plan, implement, troubleshoot, and optimize a network. Certification program yedu, we have an exam. And I think exam ready is basically to validate your knowledge, validate your skill. That is why you need to get certified. That is why you need a certificate. I think you can Uruwega or even with us, you can have the skill, you can learn everything that you need to learn. But if you don't have a certificate, ukaenda kunzoko, it will be very difficult to tell someone kuti nina have a skill, I'm an engineer, if you don't have a certificate for that. I think that's the reason why Burita 4 years at the end, more graduator, like your brothers, your sisters, or graduate my match. So at the end of it, you need a certificate. So that's the reason why we have an exam, which will validate knowledge and skill yako with respect to data communications. Why certification in different levels? Kwekutanga kwayo kune ratinokuita inonzi HCIA, which is the associate level. Then from there you go to the professional, then you go to the expert level. No need explaining. If you're an associate, if you're a professional, if you're an expert, what is the difference between that? I think the goal is to become an expert. I'll be very proud. And then I'm working on it. Hopefully we get there. You should also be thinking what in shadow expert at one point. I think it's very interesting. SCIA Datacom, it aims at cultivating network engineers with basic Datacom theories and skills. Then the professional one cultivates senior network engineers for cross-field solution planning, design, or single field planning and deployment. For the experts, solid theoretical foundation and deployment capabilities for cross-field solutions. Quiz. Which of the following type network topology is the highest reliability? You can unmute. It's time for questions and answering them. Which offers the highest reliability out of those four?
C,
Why?
because when one node goes down, the rest of the nodes can continue communication.
Okay, I'll take that. I think this is the end of our session, first session. Any questions with respect to this session? Nada. If we don't have any, thank you very much. We meet on our next session.